3.5 is about compound inequalities. And a compound inequality consists of two inequalities, so we're going to have two now, that are joined by the word either and or the word or. And to solve a compound inequality, you're going to solve two inequalities. So you're going to solve one, and then you're going to solve the other one. If it's an and inequality, sometimes you'll see it written with the word and. Most of the time, you're going to see it written like this. So notice there is no word and here. And so we will look at in an example of how you will separate this into two inequalities. You solve each and compound inequality in the same manner. You're going to create two inequalities and you're going to solve each. And so we will look at how this works. So to solve this inequality, notice there is no word separating them. And so I'm going to go all the way over until I get to the next inequality symbol and stop. And I'm going to write that inequality down. So negative 3 is less than x minus 8. And then I'm going to put the word and then I'm going to do this next inequality. And the next inequality, if I go over here, go all the way over until I get to the next inequality symbol and stop, and then I'm going to write it. X minus 8 is less than 7. So you should notice that the inside portion that's squeezed in between the inequality symbols gets repeated in both when you write them as two separate inequalities. Once you've separated them, then you're going to solve like normal. So if I'm solving for x, I'm going to add 8 to both sides. Negative 3 plus 8 is 5. Bring down your symbol. Bring down your x. And then the next one, to solve for x, again, I'm going to add 8 on both sides. Left to right, I'm going to bring down my x, bring down my less than, and bring down my 15. And so here are my two answers. And I'm going to rewrite this with the variable on the left. Remember, the symbol up here above is eating the x, so it needs to be eating the x down here. So I'm going to write x is greater than 5 and x is less than 15. And then we're going to graph this. So you're going to draw a number line on your paper, and I'm going to put on my number line a 0. Then I'm going to put a 5 because I know I'm going to have a circle at 5. And then I'm going to put another circle at 15. And I'm looking at these separately. So I'm going to start right here. X is greater than 5, so I'm going to put an open circle at 5. Greater than means I'm shading to the right. I'm just going to stop there for a second so we can look at the second one. And then I need to put a circle at 15. That's an open circle because it's just less than. And then I'm talking about less than 15. And so what you'll notice is these are being shaded towards each other. And so I'm just going to connect them to look like this. Notice I am not drawing arrows showing that it's continuing to go because it is not. It is stopping. Whoops. It's stopping at 5. Oh my, what's happening? Here we go. Let me scroll back down here. It is stopping at 5 and it's stopping at 15. So do not draw arrows past them. So when you have an and graph, you're going to shade in between your numbers because you're going to go where they overlap. The second one. So again, let's practice. We're going to write these as two separate inequalities. So I'm going to start left, go all the way over until I hit the new inequality symbol and stop. So there's my first inequality. 7 is less than negative 3n plus 1. Then I'm writing the word and. Then I'm going to do my second inequality. I'm going to start here, and I'm going to go all the way over until I hit that inequality, and I'm going to stop. And so I have negative 3n plus 1 is less than or equal to 13. Notice the negative 3n plus 1 is repeated. So now I'm going to solve. I'm going to draw in my wall. First step, I'm going to subtract 1 on both sides. 7 minus 1 is 6. Bring down your less than. Bring down your negative 3n. 1 minus 1 cancels. And then I'm going to divide by negative 3. on both sides. Reminder, when you divide by a negative on both sides, your inequality symbol is going to flip. So 6 divided by negative 3 is negative 2, and then I have n. And then I'm going to rewrite that so my variable is on the left. My symbol was eating the negative 2 above. It needs to eat the negative 2 below. Then I'm going to bring down my word and now we're going to solve this one. To solve for n, I'm going to subtract 1 on both sides. So I have negative 3n plus minus 1 cancels, less than or equal to 12. Then we're going to divide by negative 3 on both sides. Dividing by a negative on both sides means I need to flip my symbol. So it's going to look like this now. And I have n is greater than or equal to negative 4. And so there's my second answer. So here are my two answers. And now we're going to graph this on our number line. So draw a number line. And I'm going to put, since these are both negative numbers, I'm going to put my 0 here this time. And I need to put negative 2 on my graph. Remember that negative 2 would come first, then negative 4. So make sure you pay attention to how your negatives should look. Okay, then I'm going to graph this inequality first. N is less than negative 2. That's an open circle at negative 2, shading left. Then I'm going to do n is greater than or equal to negative 4. That's a closed circle at negative 4, shading right. Notice the shading is going to be in between the two numbers, which it should look like that every time for an and graph. And that's exactly what this is saying. When you graph an and compound inequality, the arrows will always cross. So you are shading in between the numbers. Now we're going to look at an or compound inequality. And there's only one way to write an or inequality, compound inequality, and it's actually using the word. So you're going to literally see the word or, and the nice part about this is they're already separated into two. You will solve and then graph. So for the first one, I have 3x plus 8 is greater than 17. So I'm going to start solving for that. So I'm going to subtract 8 on both sides. So I have 3x plus 8 minus 8 cancels is greater than 9. And then I'm going to divide by 3 on both sides. And x is greater than 3. So there's my first answer. I'm going to bring down that word or. And then I'm going to do my second one. So I'm going to draw in my wall, subtract 5 on both sides first. So I have 2x plus 5 minus 5 cancels, bring down less than or equal to. 7 minus 5 is 2. Then I'm going to divide by 2 on both sides. So x is less than or equal to 1. So here are my two answers. And now I'm going to graph them on my number line. So I have 0, I'm going to put a 1, and then I'm going to put a 3. X is greater than 3. I'm going to do an open circle at 3. Greater than means I need to shade right. X is less than or equal to 1. That's a closed circle at 1. Less than means to shade left. So notice on the OR graph, the shading is going in opposite directions this time. Next one, again, this is an OR compound inequality because I see that word there, and so we are going to just solve them separately. So I'm going to start off and I'm going to subtract 7 on both sides. So I have negative 2x is greater than 3 minus 7 is negative 4. Then I'm going to divide by negative 2. I'm dividing by a negative on both sides, so that's going to make my inequality symbol flip, and I'm left with x is less than positive 2. I'm going to bring down my word or, and I'm going to do this one. Draw in my wall. First step, I'm going to add 4 to both sides. So I have 3x minus 4 plus 4 cancels is greater than or equal to 9. Then I'm going to divide by 3 on both sides, and I have x is greater than or equal to 3. So I have my two answers, and now we're going to graph. So on my number line, I'm going to put a 0, a 2, and a 3. we're going to graph the x less than 2 first. So that would be an open circle at 2, less than is to the left. X is greater than or equal to 3. That would be a closed circle because it's also equal to and greater than. That would be to shade right. Notice again, it's an or compound inequality, and so we shade in opposite directions. And that's all this last slide is talking about, shading in opposite directions.